Hi, my name is Miguel, and today I'm going to show you how to create software supply chain attestations using Chainloop. But before we do that, let's take a look at what an attestation is. An attestation is a signed piece of metadata about an artifact or about a collection of artifacts that it's usually generated inside your CI/CD system and then used against policy engines or for auditing purposes. The way it looks is that there is a statement. There is this statement that contains subject and predicate. And the subject usually is that main artifact. And the predicate is information about that main artifact. So for example, you might be building a container image, that will be the subject. And the predicate is information about how that container image was built. And then you will put that statement inside an envelope and sign it. And that's what it will give the authenticated properties to it. And to build that attestation, there is a recommended suite already, which includes the DSSE for generating the envelope, then In-toto for a statement. For the predicate, you can use SLSA provenance or many other. In our case, we use a custom predicate type, which is an extension of the SLSA provenance predicate type. And let's take a look. Let's take a look at how it looks like. What I'm gonna do is to take an attestation that has already been built using Chainloop. And to do that, what they use is the Chainloop CLI to describe and output the attestation for a given run. And as you can see, there is this is a DSSE envelope that contains a payload and the signature. The signature then can be used to verify that that information is correct. So let's unpack it. What I'm doing now is to actually pull the statement that is inside a payload. And if you remember, that should be an In-toto statement. And the In-toto statement contains two parts. Contains a subject and a predicate. In our case, the subject has a reference to a container image that is being built. Then the predicate has information about what tool was used to craft this attestation, in our case, the Chainloop CLI. Then information about the environment, who triggered this build, what commit was used, what repository, and a set of materials. And materials can be from different types. Chainloop supports multiple types of artifacts. One of them is called artifact, which is a binary or a tarball, anything that gets uploaded to the cache and then referenced by the jest. Same, we also have a container image that contains a reference to an external container image, in this case a container image pushed to GitHub and referenced by the ID, by the digest, and SBOM in CycloneDX in our case. And the last part of the attestation is just metadata, including the runner link. Okay, so how do you create that file? And the way that you do it in Chainloop, let's say that you have a pipeline already running in GitHub or GitLab, Jenkins, whatever, that you want to start creating an attestation. The way that you will do it is first creating a reference to that pipeline in Chainloop. That's what we call a workflow. You will create a reference there and craft a contract. And that contract is a declaration of how that attestation should look like, how an attestation of the GitHub action should look like. And that includes a couple of things. One of them is in what environment should that attestation be crafted, meaning should it run in GitHub Actions? Should it run in GitLab? Then what kind of information, what kind of materials should be contained inside that statement? And once you do that, once you have that contract created and associated with a workflow, the next step will be to create an API token, a robot account that we call, that alongside the Chainloop CLI will be used to integrate to craft attestation on your CI that complies with that contract. And that's what I'm going to be focusing on today. I'm going to focus on the process of crafting the attestation that complies with a contract. And we're going to do it both locally in my laptop, and then we're going to move it to the CI to see how it looks like. So let's start with the demo. First, what we're going to do is to craft an attestation locally. And this is what you will do if you want to try it out first. You want to make sure that you have everything, all the pieces in place before you do any work on integrating on the CI. And to do that, you need three things. The first thing is the Chainloop CLI that you can download. Then you need, in order to connect this CLI to the control plane to retrieve the contract and then to push the attestation back or upload artifacts, you will need a robot account. And this robot account is what an operator will create, and it is associated with a specific workflow. So I already have one. You can expose it like that. And lastly, in order to sign the envelope, you need a signing key, a cosign key. And today, Chainloop doesn't support keyless signing or identity-based signing. So you need to provide a private key during crafting. All right, so we have those three things. How does it work? So you will use the Chainloop CLI and the attestation subcommand. And the attestation subcommand has different options. And this is meant to create a workflow that's very familiar for developers. So the idea would be that developers don't need to learn how to craft an in-toto statement, what SLSA is, or even like signing that envelope. They will just follow a familiar workflow, which basically will be running init, which will contact the control plane, get the contract, and tell you what are the requirements. Then you will do Chainloop attestation add to add any required materials that is stated in the contract. Finally, you will push, which this means creating the attestation, signing it, and push it to the control plane. Then you have other options, such as seeing the current status of the attestation, because it may be a multi-step process, or reset, signaling the control plane that something has failed, for example. So let's start with Chainloop attestation init. And you see retrieving workflow from the control plane, and it says that you cannot run it because it's in GitHub Actions. And this is in fact because the contract specifies that it needs to run in GitHub Actions. So this is a prerequisite that the attestation process happens there. This value here will also make sure that when the attestation gets initialized, some environment metadata gets injected automatically in the attestation. So going back, how can we then continue? So we can do a Chainloop attestation init with dry run mode. Dry run mode means that we are going to bypass the requirements, and we are not going to tell the control plane that we are basically playing with crafting the attestation. All right, so we have some information, but it seems that there is not any requirement about materials. So technically, we should be ready to do Chainloop attestation push. And as I said, you need to pass a private key. Once I did that, you can see I pushed it and I created a DSSE envelope. If we take a look at the content, you will see again an in-toto statement with information of subject, a predicate, and some additional metadata. Okay, that's good. But let's say that we in fact have a new contract that has 3 materials, which is more common, right? You might actually want to have something more advanced. And for example, in this case, we have 3 materials, 1 container image, 1 artifact that is called binary, and 1 SBOM. So what we're gonna do is we're gonna update the contract with the new version of the contract, a new revision. So now, if we do attestation init again, if you remember, it will retrieve the new version of the contract, and there are differences. Now we have a materials table for 3 required materials, and one of them is marked as an output. And this output is what you will basically define what a subject in In-toto is. But again, from the developer point of view, they don't know. So if we try to push, this, it will say you can't. You cannot do it because there are 3 materials that are missing. Okay, so let's go here and start adding things. So if we do, the way you do it is name attestation add, Chainloop attestation add with a name, image, in this case, and value Nginx latest. So we just added a material type of container image, and if we take a look at the steps of the integration, something very interesting you're gonna see here. Something you're gonna see is that Chainloop is smart enough to make sure that even though you pass Nginx latest, it will find the content digest, and it will also find the registry URI. So this is important because when we craft the attestation, we want to make sure that it is referenced by ID, not by tag, for example. Okay, so now let's do the same thing with the binary. I have a binary locally called server. If you say add binary and the path to the binary, the Chainloop knows that it's an artifact type and needs to be uploaded to the cache. So again, these are the kind of intelligence that the CLI has that will enforce best practices without the developer even knowing. So for example, we have this artifact uploaded here. We can technically now, if we are an operator, we can say artifact download by digest, and you will see that it actually found the server binary and is downloading it. So, okay, are we ready yet? Can we push? No, we can't because it's saying that we are missing the SBOM. Okay, so let's do the same thing with the SBOM. Remember, the SBOM is a Cyclone DX. In this case, we also support SPDX. So if I try to provide a random file or even an SPDX SBOM, it's going to tell you that this is not a Cyclone DX SBOM file. So as you can see here, the CLI is not only smart enough to know what to do with any kind of material, but also make sure that those materials are what they're supposed to be. So if I do Cyclone DX attestation add, it will upload it to the cache, and we are ready to go. You see, we have now the SBOM uploaded to the cache, the artifact uploaded to the cache, and the container image ready. This runner context is empty because I'm not running it locally. Once we run this in an actual CI, we will get this information out of the box. So let's push it. And now we have a new sign. And here it is. This is our new attestation that it has an Nginx image as a subject. And why is this? This is because in the contract said that the container image was the output. So this is very interesting because the operator can decide how to craft the In-toto statement. And then on the predicate, we have the materials. And remember, the container image, I actually pass the Nginx tag, latest tag, but no, it is properly defined as it should be. Then the SBOM, I pass an SBOM file, but no, it uploaded it to the cache and then injected the digest here. And the same with the binary. I pass a binary, but it got uploaded. So as you can see, this is such a simple way of generating a complex attestation file, and the developer actually didn't even know that it was building this. They just followed a very traditional workflow of initializing, add, and push with a set of guardrails around it. So we have learned how to do an attestation locally. So now let's do the same attestation process, but in a CI. And we're going to be using this repository that is publicly available. You can take a look. And it already has a release process. And that release process creates a Go binary using Go releaser, then packages those binaries in a container image that they get pushed to GitHub, and then uses Sift to generate a CycloneDX SBOM. All of that ends up in a GitHub release, as you can see here. So if you remember, there were three things that we need to do an attestation with Chainloop. We need the CLI that we're gonna add in as part of the release process. We need a cosign key, and we need a cosign key. Let me go here. Okay, we need a cosign key, which we already have because we're already signing the container images. We could use others, and probably it's a best practice to use other keys here, but for now it's a demo. This is the same one. So we have the key, and what we're missing is the robot account. Is basically the API token that will identify this workflow with the control plane. So I'm pasting it here, and we should be ready to start the integration. And I already have an example. I'm copying an updated release workflow, and we can see that this is what changed. One, it installed Chainloop, which is the third piece that we're missing, a very specific version of it. And then we're running Chainloop attestation init, the latest version of the contract. You can also actually put the specific one, and then do the same thing that we did before, right? Attestation add. In this case, is the actual container image that we're building. Add the SBOM that has been generated using Sift, and then take the binary that was generated and upload it as the binary material. To finish, if everything goes well, we push it and sign it, as you can see here. And if something goes wrong, there are a couple of callbacks. Let's cut a new release, and this is going to trigger a new GitHub action here with the updated release pipeline. While this happens, let's take a look, because now the attestation is actually in production mode. So that means that we go to the control plane, we can say Chainloop workflow run ls, and we can see that in fact it is in progress. So now it contacted, and we didn't need to do dry run because it in fact found that it was running in GitHub Actions. So this is looking good. So it seems they finish. If we now describe the workflow round, it's a specific one. Here it is. We have the new container image, the new SBOM. Everything has finished. So we just managed to do it, to connect this repository, this release process with Chainloop in a very easy way. We did most of the work locally. Once we got familiar with it, moving it here was trivial. If we step back for a second and look at Chainloop's approach on software supply chain attestation, what you will notice is that what we do is to make sure to acknowledge that there are two personas, SecOps and developers, and they have different priorities and different requirements. So for example, we might have operators that care about implementation details. They care about making sure that they're using the latest and greatest de facto standards, such as In-toto or signing with the Sigstore Suite. They want to make sure that all the best practices are followed. They want to make sure that the container images can be referenced by Content Digest. Same for artifacts. They want to make sure that there is a retention policy for those artifacts. And also they want to be the ones to have a mechanism to declare, a declarative mechanism to define those requirements and propagate those to the organization. On the other hand, we have developers that they already have a lot on their plate. They're focused on shipping their product. They're already doing a lot on application security. If you see my demo, in the GitHub action, we already had, they were already signing container images, they were already creating the SBOM using Swift. And probably the last thing that they want is to now become security expert and learn about In-toto, about all the implementation details, all the best practices to create a attestation. Probably what they want is just give me a simple way to comply with your requirements. And that's it. And that's what we do. That's why we make sure that there is this API in the middle, this contract in the middle. We make it very easy for developers and security agnostic. And then we make sure that we give the greatest and the latest to SecOps. And that's everything I got for you. If you have any questions, comments, concerns, please reach out. I'll be happy to chat. Thank you.